Can anybody remind me where we stopped? Because I'm doing for both B1 and B2. I am a little confused. We finished this as I can remember. Did we talk about PAN, LAN, that part? The types of networks? What is PAN, WAN? This one did we discuss?
No, madam.
Sorry? Anybody can remember? Or else I'll have to check the recording. Right, let me check the recording. Right, so we have finished that part. So we have to start the next lecture. Right, so I hope you can remember, right? We discussed about what are these different types of networks, right? Personal area network means very small network that is like connecting your computer to your printer or your mobile phone or something like that, right? Very small area connections. And LAN means usually a connection within a building, we call a LAN. It can be a large network, small network. Usually if it is within one building, it is called a LAN, right? And then campus area network means if you have several buildings or several networks inside one premises belonging to one institute, usually it is called a CAN, right? So, for example, if we have in our university, we have one network for the new building, one network for the old building, one network for the hostel, like that. So then all together connected together, they are called a CAN, campus area network or corporate area network. Both names are used. And then metropolitan area network means few LANs or can be CANs also connected together if they are within one metropolitan area, like one city, right? So then it is called a MAN. For example, let's say a bank has two or three branches in an area. Let's say one in Boralla, one in Bambalapitiya, and one in Vallavatta, and another one in somewhere like Kottahena. So everything connected together. Those are within the Colombo, right? Within a limited city or a town area. So then if there are several LANs connected within a city, so then it is called a metropolitan area network, right? So any network that is larger than that is usually a wide area network. If you consider now, let's say one bank, there are all the branches in the country are connected together in one network usually, right? So then that will be a WAN because there are several number of LANs connected in different parts of the country together. So that is also called a WAN. So the largest wide area network is the internet, right? So anything more than a WAN, metropolitan area network is called a wide area network, right? So I hope that part is clear for you. So then I will move to the next lecture. Right. So we come to the next lecture. Here we are going to first of all talk about network topologies. Right. So have you heard about network topologies? Network topologies are different arrangements in which the computers in a network or any devices in a network are connected. Different methods or different patterns in which the computers are connected. Have you heard about any topologies? Anybody have heard about different types of topologies in network? Yes, anybody have about network topologies? Right. So network topology is a way a network is arranged. Right. It can be the physical connections, or sometimes even though we don't see the physical connections, sometimes through software we have logical connections also. Right. Logical connection means it's not actually a physically we don't have a wired or wireless connection, but through the software there are connections, right? So that part no need to go into that detail, but usually there are network topologies. We have physical topologies and logical topologies, right? So topology logical means it's a conceptual understanding, right? So how the connections are made. So there are several types of topologies, right? So I'm sure you must have seen or heard of these things, right? So one is called point to point, right? So point to point means direct connection from one computer to the other computer. That is the very basic type of connection, right? And then you have the bus topology, right? The bus topology. Bus topology means you have one common connection, right? So we discussed this last lecture also, right? And you have this kind of, to the common channel, you connect different types of computer devices, right? Like this, right? So then you use a common passage to connect the other computers together, right? So then it is a bus topology, right? And then the ring topology, right? Ring means you connect them together like a ring. And then star topology. This is the most common connection that we usually have in computers. Like if you see any normal typical computer network, usually this is the connection, right? You have a device and that device have different ports, right? And then we connect the devices, right? So this is the most common practice or most common topology, star topology. Now we see in the computers. And then you have tree topology, right? Tree means now these are stars, right? These are star topologies and they are connected through a bus, right? So then it is become a tree topology. And this one, mesh topology, right? So everything is connected to one another. And then you can have number like different topologies connected together. Then it is called a hybrid topology, right? So these are the different types of topologies. Then the most common one you will see in networks, usually nowadays, is the star topology, right? Okay, right. So star topology. So as I told you, it is the most common network topology. Every node in the network is directly connected to one central node, right? So this can be a, we will learn later. There are, I mean, there are the device can be a central device called can be a hub. We will learn later. There are devices like hub, switch, like that. So any central device, we connect the computers together. Then it is called a star topology, right? So give me 1 minute. right? Sorry, right? So usually this is the most common topology. So we have one central device. The device can differ. It can be a switch, hub. We will learn later what are these bridge or bridge. It can be different devices. We will learn later what are these devices, right? So to the one central device, we connect the computers, right? So then advantages are, this is very easy to manage, right? So it's very easy to add or remove devices. And then the cable cost also compared to some other topologies, it is lost, right? Low. Disadvantages are if there is some issue in the central device, usually the connections will be lost, right? And then because all the devices has to communicate with through this one central device, if this central device is overloaded, then the speed of the network can drop, right? So those are the disadvantages. But usually in many networks, at the lower levels of the network, we see the star topology, right? So bus topology, this one we discussed earlier also, right? So I told you very small networks usually use the bus topology. So arrange all devices along one cable, one common cable. Advantages are, this is the most cost effective, right? So if you think about the cabling and installation cost, this is the most cost effective one. You can use this for small networks. Disadvantages, as we discussed last week or last lecture also, network traffic issues can be there because you are using only one common path. And if there is some issue in the central cable, for example, if there is issue here, then this part and this part will be isolated, right? So that is also considered as one of the disadvantages in bus topology, right? So then I will quickly go through this because these are not that much important, but you have to just know the topologies. What are the topologies? Ring topology we very rarely use now. In the earlier type of networks, right? Older type of networks, when we had the proprietary type of proprietary type of networks used by different institutes. I told you earlier, manufacturers had different types of networks. They are proprietary networks where only their computers or their devices can be connected. So that type of networks, we had this ring topology, but we have very rarely using this type of topology now. Can you tell me what are the what can be the advantages and disadvantages? Can you tell me what are the advantages? Any advantage you can think of? Right. So if we have this, there are actually two types of ring networks. One ring network is called this, right? You have one way or one ring, and you have the dual ring also, right? So in dual ring, usually you can send the data net this way and this way, right? So when you have this way one communication and the other way one communication, usually traffic losses are less, right? But if you have this type of network, sometimes there can be traffic issues, right? But one advantage is one send at a time. Usually one person has to send the information, other people have to wait, right? So because of that, usually we say data collision, right? Data collision means one person is sending something this way, other person is sending something this way, and then there will be a data collision and the data packet can be lost, right? So that is avoided in this ring type of network, right? Disadvantages can be when you have a failure in one point, some of the connections cannot be there, right? And also because you are using one central link, there can be bandwidth issues. But anyway, now we very rarely use the ring topology, right? Next one is called tree topology, right? So as I told you, tree topology is a connection of two star topologies connected together with a central hub, right? And then advantages, very easy to add new devices together. Disadvantages is if something goes wrong here, this network and this network will not be able to connect with each other, right? But most of the time when we arrange the networks, connect the networks together, usually you will see this kind of tree topology. And mesh topology, what can you say about now? Mesh topology means each and every computer is connected to the other computers, right? So this kind of system, what is the main advantage? Yes, what is the main advantage when you have this kind of mesh topology? Mesh topology, what is the advantage? Now, if one link fails, will there be a fail of communication? Let's say something happens to this link. This link is not working. Will it affect the computer network?
No.
What do you think?
No.
No, right? Why? Because now if these two computers cannot communicate this way, there are multiple ways it can go. Like these two computers can go this way, these two can go communicate this way or this way also, right? So there are a number of other paths you can take, right? So it is a most reliable and stable system, right? So if something goes wrong somewhere, there are multiple other ways you can communicate. But what is the disadvantage of this kind of system? What is the disadvantage?
Cost.
Cost will be very high, right? Because you have multiple number of connections connecting each other, then the cost will be very high. So we are using this type of topologies only when it is extremely important to have a reliable network, right? So let's say this is a very critical application where you cannot afford the network to be down for at least 1 second or 1/100 of a second, right? A network loss cannot be afforded. Then we use this type of mesh topology, right? Okay. Then hybrid topology means you connect different types of topologies together and connect a network. Then it is called a hybrid topology, right? For example, this is a star and this is a ring. Now these two are connected together. So then we call it a hybrid topology. Usually, if one company is having, let's say, one department, this kind of network, another department, different topology, then when you connect these two together it will be a hybrid topology. Right. So when you select the topology, what is the most suitable topology for your network? These are the things you have to think about, right? Size of the network, required speed, cost, and scalability, right? Size of the network, you understand. So for small systems, we can use bus topology, but when you go to a large system, you cannot use that. And also what kind of speed you are looking at, right? Whether you need a very high speed or low speed, and what is the cost that you can afford, and also the scalability. Scalability means whether you can add new devices to the network later, right? Because usually any type of network from when you move further, when you go to the future, obviously the demand will increase. Very rarely it will decrease. Usually it will increase, right? So because of that, we need to select a topology where when you want to add new devices in the future, it will be easier and can be done with a minimum cost, right? So that is also an important thing, scalability, when you select the topology, right? So now we are going to talk about this OSI, Open System Interconnection Model, right? So it has, this is the model, or this is the method or the standard that we use when you want to do, when we build networks, right? So usually, as I told you earlier, computers manufacturers or device manufacturers use their own systems. So when you wanted to connect one computer with another computer from another manufacturer, that was usually not possible. Let's say a person, HP computer, you want to connect with the Acer computer. Earlier, it was not possible because HP is using one type of network method and the other one is using another type of method, right? So because of that, people can the inter brand or inter manufacturer communication was very hard because different manufacturers using their own systems for networks. So then this ISO organization or international standard for international standard organization developed this standard to communicate with each other, right? Give me 1 minute. Right, sorry. So this open system interconnection model or OSI model was introduced by the ISO Institute or the International Standard Organization in order to standardize the networking sector, right? So now everybody is using, all the manufacturers are supposed to use this ISO standard for their network communication, and when they produce devices, they have to produce devices compliant to this system. So then everybody will be using the same system, so you can interconnect computers without any issue, right? So now when we think about that kind of system, like if you say today you cannot connect a Acer computer and HP computer, or you cannot connect a Samsung phone with a Acer computer, that will be like a joke, right? So because now we have very complicated system, we don't know even what type of device at the other end that we are talking when we are talking through a network, right? So that is the situation now. But earlier it was like that, usually only one single manufacturer networks were there. So then this ISO model was introduced, and after that, it was that issue was corrected, and all the manufacturers complied to this, right? So this model is very much important. You have to have a good understanding, but not the like very detailed understanding about this model, but you have to have a good understanding what is this and what we are talking about here, right? So it is called a 7-layer architecture. So it has 7 layers, right? So these 7 layers means different types of functions, right? Now, for example, let's say there are different types of devices in a network. No? For example, there are computers, right? And then there are some things called, you may have heard, although we didn't talk about yet, switches, routers, right? So now if you are using a home network, at least you know what is a router, right? So when you think about the things that a router can do and the things that a computer can do, is it same? What your computer can do and what your router can do? Which device can do more things? Yes. What do you think? If you take a computer and a network router that you have at your home, which one can do more work? Yes. Which one can do more work, or which is the more intelligent device? Yes, what are the things that now, for example, if you take the two devices, which device can interact with which device we interact? Humans interact with which device, computer or the router? Yes. Which device is more intelligent, or which device can do more work? Yes, please give your answer. It can be wrong or correct. We can discuss. Computer, right? Why do you say computer? Now, computer, we can do a lot of things, right? You can you can do like calculations, you can browse the internet, you can listen to music. Like there are so many different options or functions in a computer, and people can interact with the computer, right? So we give some command, and then computer will give some output to us. But router is not like that, right? So router is actually there to provide the internet connection from your computer to the other side of the network, right? Other side of the internet. So that is the only function, or the functions that the router can do is very limited. Now, for example, if you ask a router to do a calculation, right? Not possible, because that is not, the router is not capable of doing that kind of function. So these are different functions, right? So physical layer means set of functions. Data link layer means set of functions that the device can do. Network layer means another set of functions. Now, some devices in the network will have all these 7 layers, right? So then we call it the most intelligent device. Usually end devices like our computers, mobile phones, servers, that kind of end devices in the network will have all 7 layers. Now, for example, let's say we I hope you can remember we discussed. Now, if you want to have these 4 computers together, usually there will be some network devices in between, right? Like this. So these yellow color ones are network devices, right? So those network devices are there to provide the connection only, right? So the users are connected to these devices. So the end devices usually have all these 7 layers inside them. That means they can do all the functions of the 7 layers, right? But these in between devices or the network devices usually have a like limited number of layers. Usually they are either layer 2, that means they have 2 layers or 3 layers, right? So because their job is limited and they only want to perform the duties of these 3 or 2 layers, right? So that is the basic understanding of this model. But there are some other things you have to know. So we have to think about, we have to first of all understand why it is divided, why these layers are there in this model, right? So to understand that, we will take a normal real-time example, right? Real life example, right? So first of all, we are trying to understand what is this layer. Now consider there are 2 friends who want to communicate through a postal mail, right? So let's say you have one friend in Kandy and you want to write a letter and send it to the your friend, right, who is in Kandy. So the process of sending a letter to a friend would be complex if there were no services available from the post office. Now let's say if you without getting the help of anybody else, right, wanted to do this process, you want how you want to write a letter and send it to your friend who is in Kandy. If you are not using any other person's help, then how you are going to do that? Let's say, assume you don't have postal service or anything else is not there. So you write a letter, then what you have to do? To give it to your friend in Kandy, what you have to do? Yes?
Mention address mention.
Right, you have to mention the address there. Now there is no postal service. Then what you have to do? So if you want to send the letter, that means you have to give the letter to your friend now. That is the requirement. So then if there is no postal service, what you will have to do?
You can use any other network.
No, nothing else. I said no. You are not using any other help of anybody else. You are going to do it only by yourself, right? So then what you have to do? You have to write the letter, then take it and go to like use some transport method or somewhere, and then go to Kandy and then go to your friend's house and give the letter. So that is how you have to send. You can send your letter. Like you have to, if you want to send that document to your friend, right? So that is the way. So you are handling all the functions by yourself, right? You write the letter, you take it to whatever your bus hold, and then you go to a bus, and then you go to Kandy, and then you go to your friend's house and give the letter, right? So is that a simple process or a complicated process? Is that easy or difficult?
Difficult.
Difficult, right? So that is why we are using a postal service, right? So postal service means when you are using a postal service, what will happen? That complicated process is divided into different parts, and different people in this network or in this chain is doing that work, right? For example, now you write the letter and put it into an envelope, and let's say you go and put it into the post box near your house, and then somebody will collect the letter and bring it to your post office, right? And the person in that post office will look at the address and understand this has to go to Kandy, so they will send it to Colombo main post office, right? So at the Colombo main post office, they will look at the address and understand it has to go to Kandy, and then they will put it into a train or bus or somewhere, and somewhere it will go to Kandy. And then from Kandy, again, they will look at the address and send it to the relevant sub post office. And from the sub post office, again, somebody will look at it and give it to the relevant postman, right? Again, the postman will look at your address and go to the correct place and give it to put it into a post box. And then your friend will take the letter and then read, right? Now see here, there are about, let's say about 5-6 people involved in this process, right? And they are doing only one small parts, right? For example, you are writing the letter and put it into the envelope and put it to the post box. Then another person will collect it and take it to your post office. Then that person at the post office will look at the letter and decide it has to go to Colombo. And then person in Colombo will decide, okay, this if this has to go to that address, first of all, it has to go to Kandy, right? So then he will send it to Kandy. Then somebody will take it to Kandy, right? A bus or a train or something will take it to Kandy. Right, so there are different people who are handling only different like small limited process, right? So rather than one person trying to handle everything together, when you divide the work to different people, so there you don't want one person who can do everything, right? So you don't need one person who can write the letter and send it to, take it to Kandy and go to your friend's house and give it. That need lot of skills and lot of resources that person needs. Right? But when you divide this into different small pieces and assign them to people who have the resources and the capability to do that, then the system becomes more efficient. Right? So that is the whole purpose of these layers. Right? So in computer networks also, we have layers defined so that this complicated process of sending one data packet from one place to another place that is can be like 1,000 miles away. So rather than one person trying to do that or one computer trying to do that through the network, we have divided the work into different people or different devices. And so different devices on different layers, that means they will have different types of capabilities. So when you send that data packet from one place to the other place, like this letter went from place to place and found by looking at the address, different people decided where this has to go next, right? Like that, the devices also will look at some details on the data packet and decide, okay, this has to go here. Then from there, again, there will be a decision, okay, this has to go there. Like again, it will think, okay, next device will think, okay, this has to now go here, right? Like that, it will find its way by the help of different devices on the path and then go to the final destination, right? So that is the whole idea of this layered model, right? So dividing the work to different devices or different people who have the capability to do that, right? So now let's say this process, right? So I have put down the process. So you have a sender and the receiver. So the sender is, the letter is written, put it into the envelope and dropped in the mailbox, right? And then the letter is carried from the mailbox to the post office. then the letter is delivered to a carrier by the post office, right? Let's say now, if you can directly send this from one post office to the other post office, the post office give it to the carrier. Then the carrier will send it, take it, and give it to the required post office. Again, from the post office, postman will look at the address and put it into your, take it into the friend's house, and then the friend will read the letter, right? So now few things to think about, right? If the letter is written in French, does it affect the postal process? Now let's say you are writing this letter in French, right? The letter is in French. Now, does it affect this postal process? Do the people in this postal, I mean, the person at your post office or the person who is delivering the letter from one post office to the other post office, does these people have to know French? Letter is written in French, but in between people, do they want to know French to do this process? Yes? What do you think? Yes or no? You write your letter in French, right? Your friend also understands French, so you write the letter in French language, right? But the other people in the network, the person who is picking the letter from your post box to the post office, or the person who is taking the letter from one post office to the other post office, then the person or the postman in the next post office who is sending the letter to the post box of your friend, do they have to understand French to do this process? What do you think?
No.
No, right? So if the address is written in Sinhala or English, whichever language they understand, then it is fine, right? So whatever the information inside this packet or inside the data should not be understandable by these people, right? Because that is not their thing, their work, right? So when you want to send the letter, they are not going to read your letter, no, they will only look at your address, right? For example, now let's say this final person who is carrying this letter from one place to other post office, he doesn't even has to know how to read, right? Because this person at the post office will say, okay, you have to take this letter to Colombo, or you have to take the letter to the Candy post office, right? So then he will only understand, or he will only should be able to take that letter and give it to the correct place. No need to read the address. They don't need those complicated skills, right? For now, if you see like that, in that way, if you think the upper people or the people who are in the sender and the receiver, they should have many skills, right? So to write the letter, to understand the letter, to read the letter, they need higher skills, right? So they have to have higher capability. So they are called higher layers. They can do many things, right? So in the middle, the postman or the person at the post office. So for this process, only thing that we want them to do is they should be able to read the address and then decide where this letter should go next, right? So they don't need to know how to write the letter. They don't need to know how to read French, right? So those things are not important for those people. So they are the requirement or the skills or the capabilities that they require for this process is limited, right? Say they only have to read the address and they should be able to decide where this letter should go next. That's all. So the person who is carrying these letters, right? So we can say that the driver of the bus or the train that is carrying these letters, no need to even understand how to read, right? Because somebody will tell, okay, you have to take it to here, right? So then his job is only that delivering part, right? So he needs minimum level of skills, right? He doesn't need much intelligence, right? So we call these upper people or the people who are at the end higher layers, because they need more complicated skills, right? Even in a network, it is like that. So you have to process the data and you have to do a lot of things. And then the people in the middle, they only have to make a decision where this should go next, right? And sometimes some devices only will send the signal that you receive from one end to the other end, right? So you receive something, you pass it to the other side. That's all, right? So then you don't even want to make a decision where this should go, because you have to just pass whatever you want, whatever you get to the other side. Right? So the upper layers need higher skills, so they should be more intelligent. Middle layers need like some amount of intelligence. Lower layers need minimum amount of intelligence, right? So is this concept clear? is this what we are trying to, what I'm trying to say is clear to you? Or you have any questions? Anything you want to clarify? Right? So this is the layered communication method. So in the layered communication, these are the things that we can understand, or you should gather from here, right? To reduce the design complexity devices in the networks are divided into layers, right? So that is what I told you first of all. We don't want one device to handle the whole process of sending packet from one place to the other place. So we give the different work to different devices in the network, right? So then you can plan, or you can divide the responsibilities to different people. Then the complexity of this system will reduce, right? So each layer has its own responsibility, right? So these layers means, as I told you, different layers means different responsibilities. So if you are a device that are having all 7 layers, right? So if you are a device that is having all 7 layers, that means you have to do all these jobs, right? So if you are a device only having the physical layer, that means you are capable, or you are required to only do that layer job, right? So if you are a 2-layer or 3-layer device, that means you have to do this set of jobs. Or if you are a 3-layer device, you have to do 3 layers of jobs, right? So by dividing this into layers, we define what are the jobs assigned to these different devices. So no data is directly transferred from layer N of one machine to the layer N of the next machine, right? So that is like this. Now, when you want to send the letter, we don't send the letter from here to here, no, right? We don't do that. You are not going to send the letter directly to the friend, right? You go this way. And from your post box also, you cannot directly send it to your friend's post box. That is also not possible, right? You have to go through the post office system, right? From your sub post office directly also, this cannot go here, right? So from end to end, communication is not happening. What happens? Upper layer gives this to the next layer. Next layer gives this to the lower layer, right? So the 2 lowest layers only communicate, right? So the lowest layer here communicate with the other lowest layer, and then from that layer it goes to the higher layer. From there it goes to the next higher layer, and then finally it reaches the destination, right? So that is the concept that in the layered communication you need to understand, right? No data is directly transferred from layer N from one machine to the layer N of the next machine, right? So this is not happening, right? You cannot do like this, right? This is not happening. So that is what is mentioned by that. So you have to go this way. From the upper layers, you have to go to the bottom of your, the lowest layer of your device, and then it will communicate with the lowest device of the other end, and then it will go, right? So this is how the communication will happen. At source, each layer passes the information to immediately below layer, right? This, right? You send the information from this layer to this layer, from this layer to this layer, like that, right? Again, at the end also, at the receiver or at the destination, from the lowest layer, it will go to the next layer. From the next layer, it will go to the next layer. Like that, it will go to the upper layer where the final destination is. At each layer, additional data is added and removed from the message, right? So that we will learn later, right? For example, it is like this. Now, let's say you write the letter, and what is the additional information you put here? You put it into envelope and write the address, right? And when you write the address, and you send it to the other person, right? When you send it to the mailbox, from the mailbox it goes to the post office. Then although you cannot see that additional data is added to the letter, what is the instruction from the post office? Now the person at your post office will look at your address and decide what? Yes, what it will decide. Now let's say you are in Ratmalan. So you write the letter and put it to a post box in somewhere Ratmalan. So this your letter will go to Ratmalan post office. Now the address is Kandy. Now what will this person decide? What will the person at your post office will decide? Yes. What is the decision or what is the next step? What is the next step, student? It has to go where? If you want to go to Kandy, the letter has to go to Kandy. From Ratmalan, it has to first go where? Sorry, it has to go to Colombo, right? So this person here, although we don't write Colombo, right? So it is he is making a decision. Okay, this has to go to Colombo. So in a network, usually you add some additional device. You write another, like it is like put it in another envelope and writing Colombo, right? Let's say you just assume like that. In the network, that happens that way. So you take the letter, look at the address, and put it into inside another envelope and write Colombo, right? So then it goes to Colombo. Then Colombo person takes out, now it's the envelope says Colombo, so he takes out the Colombo envelope because that is addressed to him. So he take it out, and then he will see again the address, right? So it says it has to go to Kandy. So then he will do what? He will put it inside another envelope and write Kandy and send it to Kandy. Then the person at Kandy post office again will look at that envelope. It is not actually happening like in the postal service, but that is how it will happen in the network, right? So that is why I'm telling like that. So it will go to Kandy, and in Kandy you will look at, okay, this letter is to Kandy. So you will remove your envelope, and then again there is a letter inside that has to go to, let's say, somewhere Peradeniya. So then again Kandy person will send it to Peradeniya post office, right? Putting inside the envelope called Peradeniya. Then Peradeniya person will again open and see, okay, this has to go to this lane. Then it will go, the postman will go and send it to that lane, that house, and then you will receive, right? So although in the postal service, we don't do that envelope writing, put it into envelope one by one. You make that decision like mentally and then do it, right? But in a network, you have to do that, right? Because the other device don't know. So usually when you go from one device to the other device, usually you add some data, remove some data. You take it, you read your envelope, and if it is addressed to you, you remove the envelope and put it inside another envelope and send it, right? So that is how the data networks will work. So you receive the packet. If it says it is for you, you will take out that data. That is like removing the envelope. Then you find another address. Then you decide, okay, if it has to go to this address, that means it has to go here. Then put it inside another envelope and write the letter and send like that, right? So like that, in a layer, when you go from one layer to the other layer, usually you add data or remove data, right? So that is how the network will work, right? So any questions? Any questions? Anything you want to clarify? Is this layered communication part clear? Why we are not sending directly from here to here like this? So we are going this way, you go down and then you go to the other side and then you go up. That is the path usually networks take, right? Is it clear? Any questions? Right. So if you don't have any questions, we will move to the next one. Students, extremely sorry for this mix-up about the lectures, because I think there has been some miscommunication. Because actually what I wanted to do was, I am not able to take the lecture in the afternoon. So I told Tamila madam that I will be taking the morning lecture, and the lecture that I am going to miss, I will take tomorrow afternoon. Right? So that is the plan. But somehow there was some miscommunication when this message was sent, and then Tamila madam had thought I am not taking the lectures today morning. Right? So immediately when I saw the message only, that I put you a message that you have to log in the morning, because we cannot miss. No, we miss a lot of lectures, so there has to be cover up lectures also. Because last week also, because of my illness, I could not take lectures, right? So no, I'm not taking the lecture. That is the message that I gave to Tamila madam, but she has somehow like there has been some miscommunication, right? So tomorrow afternoon, after Niranjala madam's lecture, I will take 2 hours, right? So at what time do you finish Miss Niranjala's lecture? 3:30.
Yes, madam.
Right, 3:30. No, 3, no?
3:30.
3:30, no?
Yeah, madam.
Right. So after 3:30, I will take 2 hours, right? Extremely sorry for this miscommunication, because somehow Tamila madam had not understood what I told, right? So due to a personal reason, I cannot take the lecture in the afternoon. So I will take it next tomorrow 3:30, and then we missed some lectures last week also, no? So because of that, next week also I'm planning to take that slot also, right? So that I will let you know next week. But for tomorrow 3:30, 5:30, you will have the lighting lecture, right? Okay. So now we will go to this part, right? So this is what I told you, that you are adding or removing data to the data packet when you go from one layer to the other layer. Now let's say this is one device and this is the other device, right? So at layer 5, you have this message, right? So this is the message created from layer 5. So when you go down, when you pass it to the next layer, layer 4 will add some additional information, right? So this is like taking your letter and putting it inside the envelope, right? And writing a letter, right? So writing the address, right? So you take the letter and put it into envelope and write the address. So that additional work done by this layer 4 is called H4 here, right? And again, when you go to layer 3, sometimes, right? Not always, sometimes you copy this message and take 2 copies and put it inside another envelope and write address, right? Additional data. So layer 3 is adding this H3, right? So other than putting this H3, it is also dividing your letter to 2 parts and then doing that, right? So this can happen sometimes, this may not happen sometimes, but anyway, from when you go from one layer to the lower layer, you usually add some additional information. We call it a header, right? And then when you go from layer 3 to layer 4, you can see some other additional information that has been added to this message. Another information has been added, right? And then you go to the final layer, right? At the final layer, nothing will happen. The information that directly, whatever information you send will be converted to a signal and it will be sent to the other end. Now, other end, what has happened? Now you are in the layer 2. When you go to layer 3, what can you see? Compare this one with this one. What has happened? What has happened? What is the change you see when you compare this message with this message? Yes. What has changed? What has been changed? You cannot see any difference? This message and this message, what is the difference? Sorry? Sorry? What is the difference? I didn't get you what you are saying. Now I'm asking, now this message has gone to the other end. No? Now it has gone to the other device. So it has gone from layer 1. I told you no, but layer 1 is not doing anything. It will just pass it to layer 2. Now this is the layer 2 message, right? So from when you go from layer 2 to layer 3, what is the difference you see? Can you see this? Any difference between these two messages? Yes? What is the difference? Is it the same message that you have in layer 2 and layer 3, or there is difference? Something has been removed, right? What is that part that is removed? This T2 header has been removed, right? So when you go from here to here, this T2 header has been removed. Now see, this T2 header was added when you go from layer 3 to layer 2. This additional information was added at the sender, right? So that means sender put it inside the envelope and write some address, right? So that is what happened. So that envelope that was added when you go from layer 3 to 2 will be removed at the end, at the other end when you go from layer 2 to 3, right? So at the layer 3, the message that was there at layer 3 in the sender will be received by the receiver's layer 3, right? And this one also will be same, right? So the additional information added by one layer will be removed by the same layer when you go to the other end, right? So that is like, now let's say somebody at your Ratmalana post office, right, took your letter and put it inside one envelope and wrote something, right? And when you go to the Peradeniya post office, which is the same level post office at the other end, it will remove that envelope and put it, it will remove the envelope and send it to your post box, right? So the post box, at the post box, you will receive is what your friend put into their post box, right? Something like that. Now let's say it's like this, no? So this is the letter that you wrote with the address, right? And then this person at the sub post office put it inside another, let's say purple color envelope, right? And then the person at Colombo post office put that whole thing inside a yellow color one, right? So this one will go to here. You have the yellow color one, and the yellow color, inside the yellow color one, you have the purple color one, right? So when you pass it from Kandy to Peradeniya, this yellow color will be removed, right? So Peradeniya post office will receive exactly what your sub post office sent, right? Your level 1 post office or the sub post office send this purple color envelope, no? So Peradeniya will also receive that envelope, right? And then Peradeniya will remove this one and put this red color envelope to your post office. Sorry, your post box, right? So see, the exactly same thing that one layer did at the first or the sender side will be received by the receiver side, same layer, corresponding layer, right? So whatever the message that was made by the layer 3 of the sender will be received by the layer 3 of the receiver, right? So that is what I wanted to tell. So this additional information adding will be removed from the relevant party at the other side or the next side. Is it clear why this additional information is added and how it is removed? This additional information is required to find the path, right? To find the path, what is the next exactly place you have to go, exactly where you have to go next, right? So that information, to give that information, these additional headers are added and then they will be removed at the receiver side. So is it clear, students? This concept is very important. If you don't understand this properly, that is why I'm telling like with the this letter example also I'm trying to tell it. Because if you don't understand this, networking will be very hard. Right? The whole all the theories, everything about networking is depending on this OSI model and this layered architecture that I'm trying to explain. So any questions, anything you want to clarify? Right? So this is exactly how data will go from one end to the other end of the network. Right? So just like this letter sending example, only thing is in the postal service, we don't put this inside additional envelopes and send, no, because you write the whole address in one, right? You write the name of the person, house, lane, sub post office, main post office, everything in one address, right? So although that happens in that way in the postal, when you do it in the data communication, we put only one detail in one envelope, right? So that is how it will go. So then you will put it into like different envelopes like this and say, right? So that is how the data communication will work. So is it clear? Any questions? If you have any questions, please ask, because if you don't get it clarified, then finally it will be a problem.
It's okay, madam.
Right. So if it is okay, we can move to the next slide. Right. So this is also giving that same exact thing that I told you. Right. So this computer will make its layer 7 message, and a header will be added. So this total message will be taken as the data or the message for layer 6, and it will add another one. And then again, this whole thing was again taken as the message and put it inside another envelope. Like that, it has gone down. And finally, at the communication layer, no data. Okay, it will be only 1010 signal. So that 1010 signal will go to the other end, and the other end again, message will be one by one. This additional information will be removed. And finally, whatever the information that was sent by the layer 7 of this computer will be received by the layer 7 of the other computer, right? Okay. Right. So in the OSI model, there is another thing that we are going to talk about. Those are called interfaces and protocols, right? So interfaces are between two adjacent layers. There is an interface, right? So for example, from 7 to 6, from 6 to 5, 5 to 4, these are called interfaces, right? Why do we call interfaces? Because when you go from this place to other place, there is some additional work that has been done, right? So for example, you add this, when you go from this to this one, you have to add this H6, right? So that is the work of this interface. So that is what is mentioned, what is the standard mentioned as interface. It has defined this has to be done. This header has to be done, added. So what is the information in that header, why it is required, those things are defined in this interface. Right? So it defines the operation and services provided by one layer to the other. Right? So when you go from 7 to 6, 7 to 6 interface will add some information, right? So again, when you go from 6 to 7, this 7 to 6 interface will remove that additional information, right? So that is why we define these interfaces, right? And then you would have something called protocol, right? Agreement between two communication parties on how communication should proceed. Now, when two people want to communicate with each other, what is the requirement? For example, let's say I am a person who can only speak Tamil, right? You are a person who can only speak Sinhala. So then can both of us communicate verbally? There can be other methods of communication, but if you think about verbal communication, can we do? I can only speak Tamil, you can only speak Sinhala. So can we, both of us, communicate verbally?
No, no, madam.
No, right? So then what is the requirement for two people to communicate with each other? What is the requirement? Sorry?
Translate method.
No, if let's say you don't have a translator, you only have like, now we have to communicate directly. Now we cannot communicate. Why? Because what is not there. So if two people have to communicate, what is the requirement? Now I'm telling something, you understand that, right? Why that is happening? Now I'm telling something in English, you understand that whatever I tell. So that is happening because what?
Understand about the communication part.
Right. So both of us, you receiver and the sender, both understand English, right? So you understand English, I understand English. So we can speak in English, right? So that means you should have some common. Now English is a language, no? So language also means it's a standard. Now when I say years, you understand what is meant by years, right? So where it is defined what is years? So it is in the English language, right? In the English language, the letter years, sorry, the word years has some meaning, right? So it is like a standard, right? So languages are also standards, right? So when two of us want to communicate, we need a common language or common standard, right? So that is exactly what is called a protocol. Now in communication or in data communication, we call it protocol, not a language, right? We call sometimes language, but that's little bit different. So protocol means a standard of how you communicate with each other. For example, let's say one device sends the information 1010 to the other end, right? So then the other person has to understand what does this 1010 mean, right? So that is defined in the protocol, right? So when two people want to communicate or understand whatever the information other person has sent to you, you need a common protocol, right? So that is you have between layers, right? So I told you now, this message sent by this layer 7 will be received by the layer 7, right? So then the layer 7 of these two devices has to understand what does this message mean, right? And layer 6 of this device has to understand what is the message this person has sent, what is the meaning of this H6. So they should have a protocol, right, to communicate with each other. These two should have a protocol like that. In between layers, right? We say peer-to-peer, you have to have protocols, right? So in between peer-to-peer or like corresponding layers from one end to the other end, you have protocols. And in between interfaces, to add information, to remove information, you need interfaces, right? So protocols and interfaces are there, right? So that is interface means the communication standard between two consecutive layers. Protocol means protocol, you have a protocol for 7 layer, protocol for 6 layer, protocol for 5th layer, like that you have. Why? Because one device's layer 7 has to understand the message that the other end layer 7 has sent. So they should have one protocol. Layer 6 has to understand the message that the other layer 6 has sent, right? So they should have a protocol like that. Protocols are there between the corresponding layers. Interfaces are between the adjacent layers, right? Now, this is very important thing. Now see here what is happening, right? Now device A and device B are computers, right? So they have all 7 layers. This person is having all 7 layers. This person is also having all 7 layers, right? Device A and device B. Now, what can you say about these intermediate nodes? These are like, let's say I asked you routers, right? So routers, right? So when you take this device A and the router, which is more intelligent? Now we discussed earlier, which one is more intelligent? Router or the computer? Yes? Which is more intelligent? Router or the computer? Yes, students? Which can have more capabilities? Which device can do more things? Computer, right? So because the computer has more capabilities, it has all 7 layers, right? Now router can only do, like, it can send data, right? So there is some processing that is happening in the router. we will learn later. Now, although we call all of them routers in our common language, they are actually different. There are some ones are called routers, then layer 3 switches, hubs, bridges, like there are different devices, right? So they have some amount of limited knowledge or limited capabilities, right? Now, in this example, these two intermediate nodes are having how many layers? The two intermediate nodes, this node and this node, having how many layers?
3 layers.
Yes, 3 layers, right? So they can only do the work that is defined in the first 3 layers, right? They are not intelligent enough to do the other work, right? So what will happen is, now please listen to this very carefully, okay? Now, 7 will give a message to 6, 6 will give it to 5, 5 will give it to 4, 4 will give it to 3, while adding additional information, right? I'm not telling that. Then 3 is giving to 2, 2 is giving me to 1, right? And then the message sent by this device A1 will go here, right? So I told you, usually physical layer does not do anything. It will receive the data and pass it to the layer 2, right? Now layer 2 will look at the address, right? Layer 2 will look at the address. So layer 2, his device will see that your own name is there, right? So that means that packet is for me. It will understand, okay, this is for me, and then it will remove that additional data, right? So that, remember that additional header, this header that was added by H2, right? So that will be removed, right? So then, sorry, wait. Right. So then, when you remove that, you will see an address which you cannot understand, right? So then it will send it to. So then it will send it to layer 3, right? Layer 3. Now layer 3, by looking at that address, can decide what should be done, right? By looking at the address at that layer 3. Or that data packet that was sent by this network address, right? Because this can communicate with this one. No, this layer 3 message can be understood by this layer 3 message, layer 3, right? So then it understands what has to be done, and it will give some information to data link layer. Okay, do this, put this address, right? And then data link layer will put that address and send it to the physical layer. Then again it will go here, right? And pass it to data link layer. Data link layer will pass it to network layer. Network layer will look at this message, right? The message sent by this person. And then again, it will send it to data link layer, make a decision what has to be done, and it will give that instruction to data link layer. Okay, you have to add this. Then data link layer will add that and give it to the physical layer. And then again, it will go to the physical layer, right? So from the physical layer, it will go to data link layer. Then data link layer will go to network layer. Right? Now, after network layer, this device can understand, okay, this message is actually for me, not to somebody else, right? And then because of that, you understand that, we will learn later how it understand. Then it will pass it to the upper layers, right? And finally, this message that started from here will go to the device B, right? So if each and every device, at each and every intermediate device, it will go to the most upper layer, and then again it will be passed down. Again it will go to the uppermost layer, and again it will be passed down, and finally it will go to the device B, right? So this is the exact communication process that is happening in any data network, right? So whatever the layers you have, you will perform that duties and send it, right? It is mandatory that you perform duty. Otherwise, the packet will not go to the correct place. When we learn about one layer by layer, you will understand, right? So you have to do. Now let's assume this was at layer 2 device. This layer was not there. So then the communication will happen like this, right? And then again it will go. Then the communication will happen like this. like that, right? If there is no layer in the first device, right? Usually it is like that. First one will not have layer 3, next one will have layer 3 like that, right? So remember, this is the process. How exactly this is happening when we discuss about one by one each layers, you will understand. Right. Any questions? Right. Now we are going to discuss about each layer one by one, right? First layer is the physical layer, right? So as I told you, physical layer is the most basic layer, right? For example, if you think about that postal example, it is like that bus that will take the letter from Colombo to Kandy, right? So that bus doesn't need any intelligence. It doesn't need any, like, you don't need to read. You don't have any. You should not have any capabilities like that, right? So its only job is to send this thing given by one place to the other place, right? So that's the only job, right? Physical layer, it is like that. So there is no interpretation at this level. A stream of ones and zeros are put it into a form of convenient for transmission, right? Now, you know, there are different types of communication. We have wired communication, wireless communication. So those different type of communication devices and the communication medium are coming under this physical layer, right? So you have to just convert this one and zeros to a any convenient, or that means suitable type of waves, and send it to the other end, right? So that is the only job of the physical layer, right? So when in the physical layer, things that we are talking about most are hardware parts, right? The devices, exactly. Right. So what is the type of the cable? What is the voltage that we are sending this cable? Right. If you are using Wi-Fi, what is the frequencies? Those are the things that are that are defined in the physical layer. Right. And then other one is network interface card. Right. Any idea? Anybody knows what is a network interface card? Does your computer or your mobile phone has a network interface card, NIC? Not NIC, not the national identity card, right? NIC networking is network interface card. It is actually a little bit similar to NIC also. Right. Any device that is having a that can be connected to a computer network should have a network interface card, right? Any device that is connected to a network should have a network interface card. Why I said the network interface card is actually quite similar to NIC is, why do we use the national identity card? What is the purpose?
To identify the person. Now, in order to identify the person, what is the special feature in the NIC number?
Specific number to
Specific. Oh, it is unique, right? It is unique, right? So no two people will have the same number, right? So this NIC is also like that, network interface card. It has something called a MAC address, which is, if you consider the whole world, right? The whole world, there are no two devices that will have the same MAC address, right? So this MAC address is actually used by the, not the physical layer, in the data link layer it is used, right? This MAC address, any device will have a unique address, and they are designed in the MAC address method is defined in a certain way that no two devices anywhere in the world will have the same address, right? If you have any two devices having the same address, then there will be a huge issue because you cannot connect them, right? Because you cannot identify. So there is this MAC address which is inbuilt to the network interface card of any device that can be connected to a network. That can be your computer, laptop, your mobile phone, your network printer, anything, right? Even these lights that you can connect to network,
anyone will have a network interface card, and that will have a unique address that is unique to the whole world. Like in the whole world, there is no device that will have the same address. Now, network, our NICs are unique to Sri Lanka only, no? But this is like whole world, there won't be any other person that will have the same number. Right? So those are the things. Now, network interface card speed, right? What is the speed of your network interface card is defined in the physical layer. Right? So the physical layer, the only job is to take that information, convert into a voltage, or if you are using wireless radio frequency signal, and send it to the other end. Right? And the other end physical layer should be able to understand the voltage and convert it to a 1-0 packet, 1-0 stream. Right? So that is the work of the physical layer. Right? So in the physical layer, we have several protocols. Why do we need protocols? Because your layer 1 has to understand, the sender layer 1 sending the message has to be understood by the receiver's layer 1. Right? So to do that, you have to have common protocols. So the most common protocol, or the well-known protocol, is called Ethernet. Right? The protocol that we commonly use in networks. I'm sure you haven't heard the name. But other than that, there are some other network protocols also, like FTDI, RS-232, like that. Right? So only thing is, you have to, now when you send this data through the transmission medium, so you have to convert it to a voltage signal or a radio frequency wave if you're using wireless, and then this whatever this information or the 1010 that you have sent from this side should be converted to the other side the same, right? In order for the data link, physical layer of the sender and the physical layer of the receiver understand each other, you have to have this kind of common protocol, right? So that is the work of the physical layer. Right. So any questions?
No, madam.
Right. So then data link layer. Right. So data link layer is the next layer, second layer. Right. Data link layer is the second layer. So now let's see what is the work of the second layer. Right. Right. So now each and these layers, when you send data, so usually we have some names for this one. Now the thing that is created from layer 2, we call this a frame. Okay, this is called frame. So usually this is bits. And the thing that is created from layer 3 is called a packet. Right? So these are some names that we use, right? Other ones you don't have specific names, but these 3 packets, frames and bits, right? So in the layer 2, what the message that is created from layer 2 is called a frame, right? So this layer 3, layer 2 and this layer 2 understand what is the meaning of this frame, right? So that is the understanding, right? So data is transmitted in frames. It directs frames from hop to hop and handles errors from physical layer, right? So the main purpose, now there are some other purposes which I'm not going to like teach you or tell you in detail. There are some synchronizations happening, like timing. And then if there are any errors created by the layer 1, that also can be corrected by data link. But the most important thing, right, is this hop to hop, right? So this is the most important thing you have to understand here, right? What is this hop to hop communication? So in data link layer also there are 2 parts. One is called MAC media access control layer, which is doing this hop to hop work. And then there is something also called LAC, which is doing the synchronization, timing, error checking, those things, right? So that one, yeah, I'm not going to touch because that is a little bit complicated and you don't need to know. But this, what is this hop to hop is very important, right? For example, now let's look at this picture. right? So don't try to look at everything, only what I'm telling, just pay your attention, right? Now, A is trying to send some information to F, right? A is trying to send some information to F now. So obviously you can see this is the path it has to take, right? It has to go from here to here, and from here to here, and then from here to here, right? So that is how the communication is going to happen. Give me 1 minute. A to B, 1 hop, B to E, 1 hop, then E to F, 1 hop, right? So these connections that you go from A to B, we call it hop, 1 hop. Then B to E, another hop. E to F, another hop, right? So for the whole purpose of process of going from A to F, you have 3 hops, right? Now I told you the work or the responsibility of the data link layer is to direct frames from hop to hop, right? So that means now when you create a packet from data link layer, right? You create a packet from data link layer. The job of the data link layer is to send it to the next hop, right? So you know there will be some additional some address written in this frame, right? Now tell me, think for a while and tell me if the job of the data link layer is to send it to the next hop, right? Now from A, what is the next hop? A, what is the next hop? From A, what is the next hop? Yes?
B.
B, right? So then at the header added by the data link layer, what is the address that you every layer adds some additional information? So at that additional information, when you put it additional information at the data link layer, what is the address that you should include when you are making the frame here? When you make the frame at A, data link layer of A, what is the address it should put? If your job is to put it into the next, send it into the next hop. Yes? Now your job is to send it to the next hop, right? So then you have to add some information to the packet and send. What is that information you have to add? What is the address you have to write?
This is B.
B, right? Why? Because your job is to send it to B, right? So data link, remember, every layer has their own work to do, right? Sending this from A to F is not data link's work, right? So that is somebody else's work. Your job, data link layer's job is to send it to next hop. So from anything that is going out from A has to go where? First of all, B, no, right? So you have to go first go to B, then only it will go somewhere else, right? So your job is to put it into B, right? And then now what will happen? You write here A, sorry, B, right? Next stop is B. So you write B and give it to here, right? Give it to here, right? Now B will receive this. And it will see, okay, address is my name, right? Address is my name. So that means this is for me, right? So then what will it do? Right? What will it do? This is because this is my address. This packet is for me. I am going to remove this, right? So it will remove this header. And after removing header, what it has to do? If you remove the header, you have to put it into the, give it to the next layer, right? Layer 2, sorry, layer 3, right? You give it to the next layer, right? You give it to the next layer. Now layer 3, now from B, now from A, there was actually 1 hop, right? Everything from A has to go to B now. So then data link layer don't have to know anything. It can just put B and send, right? Now when at B, at data link layer B, can you just put E and send? Now data link layer of B, can it just put the next hop is E and send? Now data link layer at A can do that. Why? Because there is only actually one next connection connected, right? Only B. Now when you come to B, can you do that?
No.
No, right? Because you have to make a decision whether you have to send it to C or E, right? You have to send it to C or E. That decision has to be made. But that decision data link layer cannot do, right? Because it will depend on what is the final destination, right? If this has to go to D, then it has to go to C. If this packet has to go to F, that has to go through this, right? So that decision data link layer cannot take. Why? Because this ultimate address or the final address cannot be understood by the data link layer, right? It is actually understood by the layer 3. So layer 2 of B will give it to layer 3, right? Remember I told you here, right? Data link layer will give it to the network layer, right? So the same thing will happen here, right? So this packet will be given to the network layer. Then the network layer can understand, okay, this has to finally go to F, right? It has to finally go to F. That means this has to go to E, right? Next hop should be E. So the data link layer, network layer, right? Remember, data link layer will send it to network layer. Network layer will tell the data link layer, okay, next hop should be E. Right? So the network layer will tell, okay, next hop should be E, right? So then it will put address E and send it here, right? And then E, only one connection more, right? Next hop is always F. So it will put F and send it to F. And then at F, again, you have all the layers. Then you will put it to layer 3, and layer 3, it will go to layer like that. It will go up. Okay. So the job of the data link layer is always to put the next hop address, right? So if you have only one connection, you can immediately make the decision and put the next hop. But like that, if you have few connections connected, few next hops are connected to your device, then you have to go to upper layer and ask what is the next hop I should put. Then it will give you the next hop. Then you put the next hop address and say, right? So that is the work of the data link layer, right? Is it clear? So the data link layer is responsible for moving frames from one hop to the next, right? So because of that, always it will put the next hop address. That is the only thing that it is going to do. It will only put the next hop address, right? So is it clear? Any questions? So see, from the data link layer, it came to the physical layer. From the physical layer, it came to data link layer. Actually, this has to go little one more step, right? It has to go to network at B, right? Because there are two connections, you have to figure out which connection you have to send, right? So for that, you need the network layer information. Again, from the physical layer, it will go to the data link layer, and then again from the data link layer at E, again to physical layer. From the physical layer of E, it will go to physical layer of F, and then to data link layer of F, and then again it will go further up. Right? So remember, always the next hop is the responsibility of the next hop only, not the final destination, right? Final destination address, data link layer cannot understand, right? It can only understand the next hop address, and it can only put the next hop address only. That is the only work of the data link layer of any device. Right. So then network layer, right? So as I told you, in a data link layer, message is called a frame. The message created from the network layer is called a packet, right? So this layer is responsible for routing packet from the source to the destination, right? The data link layer was responsible for next hop address, next hop delivery only. Network layer is responsible for sending packet from the source to the final destination. implements routing of packets through the network, right? So to find now, network layer is the layer that will help the packets to go from one place to the other place without going in wrong directions, going from the most efficient path, going from one end to the other end is the responsibility of the network layer, right? So if that is the case, right? So this is, let's say, the packet created from A, packet layer 5, sorry, layer 3 data packet, okay, created from A. Now tell me what is the address that A should put here. Now this is the packet, layer 3 message created from A. Now we learned or we discussed layer 3 is responsible for the final destination. So what is the address that A should put in the layer 3 header? Yes, what is the address it should put? Now you are responsible to send it to the other end, final destination. So that means what is the address you should put?
F.
F, right? Correct, very good. Right, so you have to write here F, right? Right, so you put F, and then it will go to data link layer, right? So data link layer will put it inside another packet, let's say another envelope, right? Like this, no? Right. So this address will be what? Data link layer is responsible for what? Yes? Next stop, right? Next stop. So what is the next stop from A? B, right? So you will write B here, right? So this packet will come here, right? So first of all, B will see, okay, purple color packet, name is mine, right? So then it will take it out, right? So when you take it out, what will you get? The red color packet. Red color packet has name F, right? So I told you this packet data link layer cannot understand, so it will send it to network layer, right? So network layer can understand this final destination, right? So this red color packet can be only read by the network layer. So it will look at what is the address, right? So and it will see F, right? Now the network layer understand, okay, this packet has to go to F. So that means you have to take which path? Next stop should be what? If this has to go to F, next stop should be E, right? So this network layer will tell the data link layer you have to put E, right? Then this data link layer, it's very hard to draw here because not enough space, right? So then we will put E here and put the red color packet inside and set, right? Inside and set, right? Then this one will receive this. Then he will see, okay, this is for me. Now I have to put the next stop address. So only next stop option is F. So it will take out this purple color E and put F. Okay, it will put F and send it here to F, right? And at the F, again it will remove the F and take the red color packet and then read the red color packet. In the red color packet, what is the address you will see? Red color packet, what is the address you will see? Yes, what is the address you will see? Now red color packet will not change, no? The same red color packet will be sent from here. Same thing will be sent from here. So from here, when you open the red color packet, what is the address you will see? F, right? That original F address, this computer put, right? So then F will understand, okay, this packet is actually for me, right? So then it will pass it to the upper layer, layer 4, right? And then layer 4, layer 3, it will go to the final layer, and you will the message sent by the layer 7 of A will be understood by the layer 7 or received by the layer 7 of F, sorry. Right? So see here, data link layer is always handling next hop. So it is put in the next hop address, right? Layer 3 devices can understand these red color addresses, right? Now, why didn't this B? Now B has a network layer, no? So it received this packet. So why didn't it try to open the packet? Why didn't it try to open the packet? Now this layer 3 or the network device, network layer received this packet. Now it can read the address. It says F. So is he trying to open the packet? It didn't open, no? It didn't do any change to this. Why? Because of why? Because is that packet for him, for B? Packet is for B or for somebody else? This red color packet? Yes, students? Red color packet. Now we will read this, no? We will read this packet, right? So it will see, okay, address is for F. Now what can he understand from looking at that address? Is it for him or somebody else? Somebody else, right? Because it is not for you, because it's a different address. So then it is not going to do any changes. It will say, okay, this has to go to F. So I have two options, send it to C or D. So he will know from his knowledge, because there are some other additional information here. B will know, okay, if it has to go to F, it has to first send to E. So then the layer 3 or the network layer of the B device will tell the data link layer the next hop should be E, right? So then data link layer will put E and send it to E. Then E, there is nothing to check because only you have one hop. Then again it will send to F, right? So the work of the network layer is to guide the red color packet, right, from one end to the other end, because this red color packet will not change. Anything won't be done for the red color packet or the packet network packet from one end to the other end. Same packet will go. But when it will go inside different envelopes. To send it from one hop to the other hop, you put inside one envelope. Then at that hop, you remove that one and again put another address and send. Again at that hop, you remove that and again put another address and send. Right? So that is how this process will work. Right. So for the networking, actually, for networking purpose only, you will have to learn. You have to have a good understanding about the data link, physical data link and network link, right? Others are not actually part of the network. Although we will very briefly discuss what are the other layers, those are not part of the networking, right? So those are for the end devices. For these end devices only that is required, right? So for your purpose, actually, learning about data link and network layer in detail, you have to know exactly what is happening. That is what I try to explain today is important, right? So any questions? I will stop from here and you will not have that afternoon lecture. Very sorry for the miss up. So anything you want to clarify? So please, again, try to revise what I told you. Just take 1 or 2 minutes and think actually and see what is happening. Right? So please see what has happened. Try to understand it by yourself. And then next week when we start the lecture, if you have any issues, please ask. Then we can discuss about the other layers in detail and go to the other part of the lecture, right? So remember, understanding what is exactly happening in data link layer and network layer is extremely important. So that is what I try to tell you today, right? So any questions?
No, madam.
So this one we will discuss in detail later, right? So what is exactly happening in this network layer and data link layer? Further, when we talk about the network devices, about switches, routers, hubs, then we will discuss this again in detail, right? So, but the concept you have to understand now, what is the work of the data link layer and what is the work of the network layer. Now, you may like seem very simple thing to you, but when you go into detail, you will understand how complicated this actual concept is, right? So remember, data link layer work is to ensure the next hop correctly and put in the next hop address correctly. And the network layer's main job is to put the final destination address and routing the packet from the one end to the other end, right? Because obviously when in a large network, when you go from one place to the other place, sometimes you may even pass 100 or 100, like, I don't know, maybe many, even 100, 200 devices, right? But from that one end to the other end, this whole, the packet, the red color packet will not change, right? Only thing, when you come to this kind of junction where the next stop has to be decided, right? So at B, you have to decide whether you have to go to C or E. Then that packet address, red color packet address will be looked at the network, from the network layer, right? Because only network layer will understand this red color packet address, right? Data link layer cannot understand. So like what happened here at B, you looked at the address and understood this is for F, and then the network layer told data link layer you have to send it to E, right? So same way, if you found a packet that had the address D, then it will say you have to send it to C, right? So in the actual scenario also, in number of places, the network layers will look at the final destination and decide, okay, you have to go this way and you have to go this way. So routing that packet from one place to the other place correctly, according to the final destination address, is also the work of the data link network layer. So that is why we say that network layer's job is to send the packet from source to the destination correctly, right? So you have to do the routing. Routing is deciding whether, now when you receive the packet here, whether you have to go to C or E, right? Again at E, if you say there are 2 or 3 options, then you have to decide, no? So that is called routing. So that part is done by the network layer, because the network layer is the only person who can understand the final destination address. This is F, right? Or D. That can be only understood by the network layer. So it will understand, and then it has a database. These addresses you have to go this way, these addresses you have to go this way. So looking at the database, it will decide and tell the data link layer what is the next hop, right? So I hope it is clear. So if you don't have any questions, I will end the lecture from here. I hope you have done all the assignments that I have given you. Because as I told you earlier also, when I give the eligibility, I'm not going to consider anything else, but you have to, by the time I'm checking for eligibility, you have to have those things submitted, right? So if you have not submitted them, please submit them. And because ultimately when I decide on the eligibility, please don't call and tell me that you have not submitted due to these reasons, because I give you time. But by the time I check for eligibility, you will have to complete everything and keep, right? So because of that, I'm reminding you time to time, because I also understand you are working, so you have some other commitments also. So that is why I'm a little bit flexible. But please, whatever the assignments I have given, go to the LMS and check whether you have done them. If not, please complete them and keep, right? Because when you come to the end of the semester, there will be a lot of work, right? So then you will not have time to do these things. But these days you don't have much assignments to, so please keep them, please complete them and keep, right? So then thank you everybody for joining. I will see you tomorrow for the lighting lecture day, right?
Thank you.
Thank you.